Here we go. So quickly, just to show you where we're aiming for, what I've done is first of all introduce these axle pickups. These are from DCC Concepts. These are a superb way of getting power to any vehicle. They come in packs of various quantities. If you're modelling in TT or N, the 1.5mm diameter springs are the ones you want. They also do one which is suitable for 00. These are brass, but then they are also gold plated. That makes them really nice to solder to, and they are excellent pickups, and they have virtually no drag in the wheel at all. What I do is I put 2 pickups, one on each axle, and so effectively I've got one polarity picking up on one bogey and another one on the alternative one. So what we'll do is have a quick recap on what was fitted. I was using this little arrangement, and I will do a link to the battery powered one if you're interested in that, and also a list of all of the bits for this conversion or this version of the lighting to do mains, or rather track power. So you should be able to get your hands on all the bits and pieces that you need. So that's what I was doing previously, which was adding this small battery pack. So you can buy these holders, the batteries. Then you would be using a latching reed switch, and that's the type of switch that when you bring a magnet to it, it will move it either to on or off, and then the tiny magnet on the top will hold it in place. That's the latching part of it. There are reed switches available cheaply, but they only make or break the contact as and when the magnet is brought near them, and if it goes away it resets, so there's no latching mechanism. Unfortunately, the non-latching are the really cheap ones that you can get 10 for a penny or something ridiculous, but this is the more expensive one. I've only really found one reliable supply for these. The other component on here is something called a resistor. In the lighting, in the battery lighting kit, what we were using this for is primarily, or rather only solely, to set the hue of the lights, in other words how orange or yellowy they look. Modern lights tend to be quite bright, almost a blue-white, and an older stock, things like a Mark I coach, they used incandescent light bulbs in the real thing, so if you can get a nice yellowy light. And by increasing the value of this resistor, you can change that appearance of the light. When you go to track power, if you are either in DCC, which I'm going to presume most people who are looking to do this will be, because that's a constant power supply to the track, that can be anything between 12 and 14.8 volts, 15.8 I think, possibly, depending on how you have your setup. Larger scales will be different, so you'll need to refer to various charts to know what size of resistor you'll need. You can calculate it if you remember your secondary school physics. But what we do is, on those, to get the track power back down to a power that the LED strip can cope with, we don't change the voltage, we change the current. So you put a resistor in and it chokes it down, and that enables you to get to a setting where the LED will start, it will light up, but it won't blow. If you try putting, say, a 5-volt LED, which is probably most of them, something like that, if you put that onto a regular DCC track supply with no resistor in, it will probably go pop. How quickly it goes pop depends on how much power you've actually coming through your track. So that's just a warning and just something to be aware of. It's not difficult. I found the best thing to do was relatively inexpensive. Buy a selection of resistors. There they are. They're very, very cheap. These come obviously with a rating on. You can calculate them from the different coloured bands, but I do like to leave them in the packet because life is too short to go around trying to work it all out from there. So you've got different ones. Here we go. This one is a 5.6k ohm resistor. There's a rule of thumb: if you put a 1k resistor, so that's 1 kilo ohms, on anything that is going to be taking power from the track, that will reduce it down to something that an LED will be able to cope with without going bang. In fact, most accessories that have lights in will come with something like a 1k resistor. But if you notice, I've got those other ones, a higher one, a 5.6, so that means that not only will it work, but also I can get that nice yellowy look that I want for my Mark 1s. So that's what we're replacing if you already have battery, or you can take that out of the build of the previous ones. We have something to pick up power from the wheels. And the other thing we're going to do is make this little component here. It's 2 capacitors in series and something called a bridge rectifier. And components, this is what they look like. As I say, I'll do a list of the bits. You can get them dead easy on things like Amazon, eBay. Maybe I'm going to call it YouTube there. This is YouTube. And also you can get things like on this on AliExpress, depending on how quickly you want it. It just depends on how cheap they are, but these really are quite inexpensive. The battery pack kit, I reckon, was costing about £4 per coach to do. This is probably under £3. So the capacitors, they enable you to have the lighting, but if it goes over a poor joint, you don't get any flicker. So just like a stay alive for a locomotive, these hold a certain amount of power for a very short length of time. And that will mean that the lights stay illuminated, even if it goes over a set of points. Because bear in mind, although we've got 4 pickups, it's 1 polarity per bogey. So there are situations where that might not be perfect pickup on your track. That will counteract that for you. And this little thing, the bridge rectifier, has a series of diodes inside. And if you look at the, and hopefully it's going to come out, if you look at the symbols on the back, you'll see you've got 2 wiggly lines. Those are the symbols for an alternating current. DCC track power is effectively changing from polarity between rail to rail within a certain frequency, and that's how it manages to send the information down the rails for locos. But an LED won't work with that. It needs to have a constant positive and negative supply. And so this little device here, what it does, it takes the alternating current as it comes in and it filters it, ensuring that you have a set positive, which is marked with a little positive on there, and a negative. And so that is safe to work with your and will. So far on all of the TT120 coaches, it seems to be that you will have a tab at each end on either side, in the center and at the rear. The best thing to use for a tool that's not going to do any damaging is a nail, but if you haven't got, as in a finger or thumbnail, if you haven't got that, possibly use a thin but fairly strong blade so that if you do bend it, it doesn't shatter. But all you're looking to do is to pull this away. You might be able to see there is a gap just on there. You can just see where I've got the blade, possibly that there is the tab of the chassis that engages. So I'm not going to use a blade today because my fingernails aren't short at the moment. Just going to pop. You can see it does sometimes take a little through. There we are. And then once you've got in, that one came away quite easily. Once these have been on and off a couple of times, you find that they do tend to release a little bit easier. But run your thumbnail or whatever the device you're going to use in there is. You've got the other side as well. You might need to just open those out. Now this has got some wiring in it, so I'm not going to just let it drop. And here we go. If I pop it this way around. And here we go. Right. Voila. So if I hold this round, what we have here, this is the LED strip. And for the sake of showing you, I'm going to take all of this out. So with this particular example, these are the Mark 1 coaches that I repainted in blue-grey. And whilst I was doing it, I also took the opportunity to paint the interiors. And I also put some people in. You'll notice they're all They've all been suitably operated on so that their little legs aren't too long. So we've got my little pack at the end here, and you have these two spurs on the end which are picking up a track feed from each bogey. This is fitted with a little bit of black tack just to hold that pack in place. That just makes it easier for fitting. Then a piece of this COB, that stands for chip on board LED strip lighting. You can get this in huge lengths. Often you can get it with a USB connector on the end. It's really intended for when people want to put things like under cupboard lighting in their kitchen and various other lighting effects. It's great for model railways. You can also keep the USB on so that when you get it, you can check that all your lights are working really easily. You'll see that we have the battery pack, and then that is soldered directly to one terminal of the LED strip there, and on this one that's the negative. Sorry, rather that's the positive. The negative's on the other side with the resistor on. And if I flip the connector up, you'll see that that's my positive side of the LED strip. It's marked 5V plus, and the other side is the negative. The V that I cut in here, that was really intended to accommodate the latching reed switch from the previous version of doing these. So you might not need to have to do that. You do need to be aware though that wherever the resistor goes, it will take a little bit more height space up, but the rest of the light strip will fit because of all these little slots that are cut out in the interior. And that is to me, that's an indication that these were possibly intended, or potentially in the future, Hornby may do a lighting kit. So there we go. That's how it fits into there. What we're going to do is, first of all, have a look on making the little pack. That's dead easy. Then, because I've done all of my coaches, I'm going to have to do a little bit of disassembly. Just show you underneath. So I've wires just come through the center. So once they've been soldered to the two contacts, and I'll show you how you do that, they can pop up through the space, or rather the pivot, which is hollow in the center of these. Really useful for this. Out through here. I've just looped this round so you have a little bit of excess, so that at no time is that pulling that wire on there. And then trim that down, stick it in a couple of places, and we're good to go. So, and this is where lighting 2 takes over. So if you'd have watched the video previously, this is the bit that's different. If you didn't watch the original video, you don't know what I'm talking about. Anyway, fortunately, 2 very eagle-eyed contributors spotted that I'd done something which was unnecessary. It wasn't particularly that it's going to do any harm, but I'd wired up 2 capacitors in series, which is just not really achieve anything for this application. So the little pack that we are going to put in to power the lights and make sure that they are flicker free, we're going to cut it down from 2 capacitors down to 1. It's actually going to work better than the way I had it before. And the other important thing, whilst I have removed a little bit of the interior to fit this little pack in, by dropping down to 1 capacitor, I know that we will be able to get it in to the toilet area without having to take a wall out. So if you're a little bit concerned about cutting some of bodywork away on a model, you can put your mind at rest. You don't need to do that. In fact, all of this alteration, you can basically add it, and once we've done it this way, it means you can take everything off and return it right away back to its factory condition if you wanted to do that. Right, so what we're going to do is we're going to use 1 of these capacitors. These are the ones that are listed in the little shopping list at the end, and we're going to use our bridge rectifier, and I'm just going to attach that onto the back, make a little pack up, and add the resistor, and then that's ready to go onto the coach. So that's the next thing we're going to do. As I said before, the bridge rectifier has got a little positive and negative marked on it, and it's important that you get those the right way around to match the terminals on your capacitor. And what we're going to do is we're just going to fold the leg round. I'll do them one at a time. I'll use a little bit of black tack just to hold that in place whilst we add some solder. Here we go. Of course, the other advantage of only using one capacitor is I'm going to save a few more pennies. So that is one secured in place, and then we're going to fold the other leg round. Don't worry about that all being in the way. Once we've got it soldered, we'll trim the excess off. There we go. So we've got that soldered to the positive and the negative terminals of the bridge rectifier. I'm going to trim the negative one because that's the one I'm going to add the resistor to that. And then we've got these other two that are going to pop out, and they're going to be the ones that pick up the track power. Before I leave this job, the next thing I do, I'm just going to tin the insides of these contacts, because it will make soldering that a little bit easier when we come to do it. There we go. Now, I've left an extra length on the positive, that's the long leg on the capacitor, so that you could use that instead of adding an extra piece of wire. You could use that to add to the LED strip. And then the other thing to do is to add a resistor. Now for the Mark 1s, I have chosen to use these, and I just double check, yeah, they're 4.7 kilo ohm resistors. And just like when you were putting the capacitor on, all you need to do is, I think it just makes it a little bit easier if you wind it round the leg of the bridge rectifier. Just holds it in place so you get a nice tight seal. Now the resistor itself, I've just popped in the middle there just to make it nice, neat and tidy. That's insulated, so you don't need to worry about the actual body of that making contact with anything. And then again, I'm just going to pop a little bit of solder in there. There we go. And then once that's in place, we can trim down both the leg of the rectifier, and we can also do that on the end of the resistor. So you've got these two extra bits on here. It saves just having a whole bunch of extra wires on, and then all you need to do is pop that into the coach. Now I did say that you can fit this into the toilet area now without having to remove any part of the toilet area itself, and if I just show you, that fits in there nicely. The wiring, obviously you can just maneuver that round and get that round. You don't need this extra bit on here, so for example that would be removed. Your track wires can come up through the little slot here and they can just attach onto there, and again any excess you can just nip that off. And of course these legs, you can fold them up as long as these don't touch those. You can fold either one of those either way. I think nip these ones off once you've soldered it, solder to those, and then just fold those up, and then you can just attach to these pads on here. Now you'll see some have got solder on already, some haven't. All you have to do is warm that, add the solder, and you'll get a nice blob of solder. Some come with some blobs of solder on from the factory ready to use, but you can add these along here, any one of these pads. You don't need to use the nearest one. If you have a long piece of wire, you could put it over here if that's what you want to do. So I'm not going to show you how to wire that in because I think that kind of really makes sense. I'm going to show you on the one that I have done so you can see we've got a resistor which has gone to the negative, so that's fed from this negative side of the capacitor with the stripe on it. On this one I used a little bit of wire because I'd cut that one short, and so that one is just soldered onto here, onto the positive. It's important that you get the polarity right with LED lights so they work, so everything is polarity dependent once it's gone through the bridge rectifier. But the thing that doesn't matter are the wires that come from the track, which I've soldered to the input side. So that's the bit on the sticking to that. If I grab this, so it's the one that's got the wiggly lines on. That's your input. So just to recap, that's here and here. Outputs, positive, negative. Inputs can be whichever way around, it doesn't matter as long as they're different. Okay, now to the next stage. Just pop the bogey off. That just makes it quite easy. It's just literally a pull and these two tabs will release. And to release your wheels, we need to do, again, it's a little bit of pulling on the inside of the bogey frame. If it doesn't come cleanly, do both sides and that will release it. This is quite flexible plastic. This is a godsend these days because in the old days, stuff like this used to be quite hard, and if you were pulling wheels out, you had to be so careful you didn't snap something because the plastic used to be quite brittle. But that's really nice modern plastics, got a little bit more flex on them. Now I've got the two spring contacts. I've actually removed them from this bogey that they were installed in, but I'm going to show you an easy way to take the wheels off. You can just twist them and pull. Some people find that a little bit hard. So here's a little trick that you can do using a pair of pliers. So I've in the past said about these pliers being really useful for setting, it's actually these ones, but there's a whole set of three. These are great for setting the back-to-back measurements, and I'm going to use this for putting these back together. But to take them apart, if you notice, you've got a little bit of a groove there where the hinge of the pliers is, and if you take the other one there and you can twist that, and that will pop the wheel off that's got the, usually it's the one that's got the plastic insulation on the inside. You don't stab yourself on any parts of it, and it comes off nice and cleanly, so you don't overlise this hole as you take it out, because that could make it a little bit more unstable. Okay, so both of these wheels, that's the one. So this wheel is transmitting power, or is electrically connected to the axle, because there's no isolator, no insulation in there at all. And what I'm going to do, I always do it the same way, so that then I don't have so many times of having to look to check and make sure that I'm not trying to attach all of the wheels with the polarity or picking up off the same rail. So just slide that spring on there. If these come a little bit connected in the packet, don't rive at them, don't give them a good old tug around, because you will bend them. And if you bend them out of their shape, you'll find that they can pick up on the axles, and that's how you get drag with them. But ordinarily these are absolutely fantastic. So again, the metal wheel onto the axle, that's the one that's going to have the little bit of the leg poking out of it there. Just gently pop it on, and then to stop it getting lost, for now I'm just going to push the wheel back on. Do be careful poking these on, because the pinpoint is super sharp. You'll do it a few times and eventually you'll learn. Now the next thing to do is to set the back-to-back properly on these, and then we can start putting everything back together. Again, I'm going to use the tools that I've got. So I'm going to use a couple of sets of pliers like that, and that's going to become something just to hold it. And I'm going to pop the wheel so that the pinpoint axle that's already set, that's just going to sit in that recess there. And then with the jaws of this set of pliers, which I know this measurement is 10.43 millimeters from that face to that one, and that is ideal for setting the back-to-back. Careful not to nip your spring. If you now hold that, and that's going to act as the stop, and all you need to do is firmly press down on the wheel, again avoiding poking your fingers onto the pinpoint there, and that has now set the back to back as well as pushed it on dead easy, and it's all gone on square. In the factory they'll actually have a jig which will be not the same idea, but I'm hoping a little bit more sophisticated than this. Maybe a little bit more engineering involved. And I've said many times, if you ever have derailment problems, pickup problems, one of the first things that I would actually always start to look at would be the setting between the back of each wheel face, because that can seem to cause so many problems. Okay, so now we've got those in, we're going to pop those back into the bogies and we'll move on. I've already got these bogies set up, so I just need to make sure that I put them in correctly, so I'm picking up from both rails. So if you look, I have them so that the contacts are picking up off this lower side rail as it would be at the moment, and remembering that this cutout goes on the back of the coupling, so that would go there. So I need to make sure that the legs of those pickups are at this top piece. Normally when I do them, I've got a whole pile of bogies sat there, and you just do them thinking that's on the right hand side, therefore the leg for the spring pickup needs to be at the top. And again, just carefully, you want to avoid catching the spring part, and if it goes into catches on one of the bits of moulding, just carefully pop it away. Do make sure you get these into the axle box and give them a little spin, and you can see that runs like a stream. And we're going to do the next one. And I think I might get that to pick up on the camera. And again, it's spinning. These DCC Concepts pickups are absolutely superb. Now, I've borrowed some of the ideas of this from Richard at This Way Works. He said, do another version of it, see what you can come up with. And Richard actually showed how you could make very cheaply with a piece of brass strip contact on there. But for the amount of money that these cost, and the fact they work so well, and I think these are a little bit more in the realms of a fairly sort of average modeler. You don't need a huge amount of skill to do this at all. You'll pick it up quite quickly. I think this is a really achievable way to do it, and you might look at them thinking that 20 odd quid for a little packet of pickups is a lot, but when you work out how much it is per coach, it's not very much, and they just work. So I think it's a good idea, good investment. So we've got those two in there. The thing that you might be thinking now is, how on earth do I going to solder those two together and a wire? And there's just a little trick to doing it. So we shall get some wire. I've stripped the end of this wire, and I've also tinned it slightly with a little bit of solder. And then what I'm going to do is I'm going to put a hook in the end of it, and that is the bit that's going to make this a whole lot easier to get together. Pop the wire through the center of the bogie, like so. And then what you're going to do is hook the two parts of, or rather the two connectors. Well, I say it's going to make it a lot easier, but trust me, it does. I've trimmed the insulation off at the end of the piece of wire, and then I've tinned the wire, so I've added some solder to it, and now I'm just going to put a little bit of a hook on the end of it. The bogie with the axles in is being held on a bit of black tack, and then the next thing I'm going to do is I'm going to lift the contacts out of the way for the moment, and then I'm going to drop these in on top of the hook and hold that in place. So here we go. Once you've done this a few times and not tried to film yourself doing it, it does get a lot easier. So I've got it all in, everything's been tinned, so just going to add a little bit of heat, and that's the job done. So that now is soldered to there, and it's also secured each axle to the other, so the leg of it isn't spinning around or anything like that. So once we've done that, all we need to do is move that blob of black tack. Try and get that a bit closer so you can see. It doesn't need to be a huge solder joint, it just needs to be enough to hold it. And we're just going to, sorry, I'll do that on camera so you can see. I'm just pulling the wire through. Might just bend that end over because I can. There we go. Jobs are good, as they say. Right. So now we have our wire coming through the centre. We'll feed the wire first. It's a little bit more fiddly because I've sort of semi done this and then half taken it apart. Just pop the bogey back in. You find it's easy just to push back on one of the tabs on the side there and click it into place. You'll feel when it's gone all the way home. Bring your wire out of the way, and then you need to push that up through the gap in the floor and thread it through. And then this is the wire that we're going to attach to this terminal here. As I remember, it doesn't matter which way round you do these inputs because they're designed to be an alternating feed. So what I want to do is give myself a little bit of extra wire. Even though this is asking way more than what these are designed for, I find these do work quite well. Strippers. I think we'll, just for the sake of it and making life easier, we're going to tin this wire a little bit. And I'll fold it round into place using the tweezers, and then we'll solder that back on. Okay, so there's my tweezers. Just going to stop this from moving about, and then because I've got solder on both components, I should be able to just put some heat on, and that has stuck nice and firmly. It's a good solder joint. Okay, next thing to do is test it, make sure that works, and then refit the body. Always test as you're going along because it's a lot easier to make any adjustments and any changes. Make sure your wires are well out of the way. I'm just going to pop that back in there to there. So I'll just pop this on the track and make sure this is working before putting the roof back on. Well, tried that. It worked. I knew it was going to because it already been done before, and it is a really easy job. If it doesn't work for any reason, just check your joints really. So make sure you put the roof or the body of the coach on the right way. So remember, the toilet windows actually will go up against the apertures here. The great thing about these is you don't see how I've had to remove this section to get that block in there. And that literally just pushes on. As always, just be gentle Don't need to force anything, it just all nicely clips in place. And whenever you're fitting bits and pieces back, just be careful about applying a lot of pressure to the underframe detail, because it is possible to break that off. Okay, so that's that done. We'll bob over, stick that on the layout, but I'm going to bring a Mark III over and I'll show you just how you can hide all of those components without having to cut anything out of the actual molding of the interior. Here we are with a Hornby TT 120 Mark III coach. These are the ones that are suitable for running with the HSTs. You can see that is my COB light strip, which has been just stuck to the roof of the body, and we have two leads coming off there. Now you'll notice I did cut the toilet section away on this, and that's because originally I did have the battery pack running in these ones. Also, I've done a little bit of painting on the interior, and when I just add passengers, I find that once you put the lights in, it does tend to show the interior up a lot. So a little bit of colour just on light and the seats and on the tables and things just help. But the main reason for showing you in here is how I've dealt with the capacitors on this side sitting in this channel over here, and then we've got the bridge rectifier sat here, and again it has got a resistor. Mark 3s would have had much brighter lighting than say a Mark 1s and things like that, so this is a lower rated resistor. I can't remember off the top of my head what it is. I say as long as you have at least a 1K in, you won't blow 5V LED lights, and if you start going bigger, you can really start to trim the light effect so that you don't have it too bright. Some coaches, fortunately it's not the TT 120 ones, they seem to be quite resistant to light bleed. That's where the plastic bodies themselves let light through. These are actually made from coloured plastic and then paint added on top as well, so they seem to be a little bit more resistant than some of the older or less exotic design of coach. But that's how you can do it without having to cut this section off. And then what we'll do is just pop this back together, and then go back onto the layout. So that's everything all back together. As you can see, I've done the Mark 1s. These are the ones I repainted. This is the one I've just been showing you how to do the job. It's a very similar process on the Mark II coach. You do need to remove some of the toilet wall. You could separate the components, I guess, and have capacitors at one end and the bridge rectifier at the other. That just means putting a lot more wiring in, and of course, as I say, you can install it in that underframe section on the Mark IIIs. So thank you very much for watching. I'll put some links. I'll also do a link to Richard's fit on the Mark III coaches if you fancy making your own wheel pickup rather than using the DCC Concept spring ones. Makes it even cheaper. Do keep making the comments and asking any questions. Always happy to help out where I can, and it's always great having the support. Happy modelling, and look forward to seeing you on the next video.